Okay, let's look at some of the applications of double integrals. So first we're going to take a thin plate, and this is called a lamina. And let's take this thin plate as a region D in the XY plane. So we have a thin plate in the XY plane, so it's laying flat, it's flat, and we take this rectangle and a point in that rectangle, and we're going to divide that whole region into little rectangles. So that's really the point xi, yi in the rectangle I. Okay, and then we represent density at a point is represented by a continuous function rho. And for this rectangle, delta M is the mass. Let's call it rectangle R. And delta A is the area. And again, we're going to divide that whole thing into little itty-bitty rectangles. And mass is equal to density times area. So the mass of the whole plate, we're going to add up, it's going to be approximately the sum of all those rectangles. Where ij is a point in the rectangle, so we have the density of the rectangle at a certain point in the rectangle, and then times the area of all the rectangles. We add them all up. So this right here is density. This is right here is the area of each of those rectangles, and density times area is mass, and we add them all up, and this is a point in each rectangle where the plate, the thin plate, is divided into rectangles, little rectangles. So if we take the limit as the rectangles go to infinity, then the mass is going to equal this double integral over the plate of the density at a point times dA, the area. Okay, so there's one application. Another one is electricity, where there's an electrical charge on the plate. And we're going to say sigma is the charge density. And then we say the total charge is going to be the double integral over the charge density, again, times the area of the rectangle. So it's just like the other case where mass was the double integral of density times area. Okay, and then let's talk about moment. We call moment in two-dimensional is mass times the distance that the object is, or the point is, from an axis. So when we move this to 3-dimension, and we do it with respect to the x-axis, then we have this point here, and that distance we'll say is y star. Okay, so we have the mass, which is the density times the area. And again, we're taking little rectangles, and then the distance from the x-axis is y star. So this changes to this formula. When we add up all the rectangles, we have two sums, the width and the length, and so we have the double integral y times the density at x, y, dA. So that's the moment with respect to the x-axis, and the moment then with respect to the y-axis is almost the same. It's not the y-axis, so the distance is going to be x here. It's the only difference. And then the center of mass is defined to be the moment with respect to the y-axis over the mass, and y bar is moment with respect to the x-axis over mass, where, if you recall, mass is the double integral of density, which we use rho, times the area of the rectangle, and we do a double integral to get that. Okay, so to see some examples, look at the sample homework problems.